I'm CK. Tonight, another eBay special, little WHDTS Practice Soldering Learning Elect, new, made in China. I believe this is a little self-guided car. We'll take a look at it, see how much fun it is to put together, and see how much fun it is to experiment with afterwards. This might be a really fun kit for a beginning builder. Hope you enjoy it. Let's see what we have in the bag. The parts tray ready. See if this tears well. It does. Oops, where's my garbage can? Open this Ziploc type fastener, and got a bag full of stuff. This looks like a bunch of mechanical stuff. There are gears. I'm sorry, there's a bunch of stuff. There's gears, there's resistors, there's trim pots, there's on-off switches and screws and LEDs. A whole bunch of stuff in there. We've got one little DC motor, permanent magnet, another little DC motor, permanent magnet, battery holder for AA batteries, then take the rest out of here. Here's the board where you put the motors and the switches and the battery box and the IC with the logic in it. And here is a little test track. So there's going to be a sensor that's going to guide the little car around this black line, and as you can see, calls out runway width is 15 millimeter. So if you want to make your own, you can, I assume, get some white paper, put a 15 millimeter black stripe around it, and it'll follow that. I'm going to go put the, oh wait, here's the back. Smart Tracking Car Do-It-Yourself Kit. Yep, there is a 16 millimeter wide black runway in a white field. That says 15. Ah well. Okay. The light is reflected through the ground to the photoresistor. By detecting the resistance of the photosensitive resistor, can determine whether a car is driving in a black area. If the detection is on black runway, then the car to change direction of driving and motor will slow down or even stop, and then the car to change its direction of driving and the motor will slow down or even stop, and red LED off on PCB front side. Drive the car in the opposite direction so that the car is always running along the runway. The rear side of the assembly instructions is an easy track for this. Yes, okay. You can also use the black electrical tape directly on the ground to design the complex runway. It would be even more fun. That's a good point. Let me see. So here's a roll of black electrical tape, and yeah, it'll fit almost exactly. So that's what we may do. We may put the black tape on the floor of the workshop out here, even though it's kind of gray mottled concrete, so it might not be the contrast that's required, but we'll see. And here there's QR codes to get a more detailed manual, and then just a bunch of instructions. So the question I really have is, where are the wheels? I think I see some, yeah, I see some black rubber bands in here. Let me dump all this stuff out. I'm going to take the motors and the battery box and put them over there. And there's one rubber wheel, for the lack of a better term, a little 3-conductor ribbon cable I'll put in that bag. Some resistors, more resistors, resistors. The photoresistor that's going to do the tracking. Speaking of tracking, are you going to track focus? Okay. Another rubber wheel. Electrolytic cap. LED. A quality inspection tag, so somebody checked this. A trimmer. Socket. Oh, there are 2 photoresistors. Kind of makes sense, doesn't it? There's one wheel that these rubber rings will go around. Driving gear. Another wheel. On-off switch. A red LED. A gear. Spacers. 1 transistor. A nut. A drive shaft. I'm going to assume that's going to go oh no, that's not the way it's going to go. We'll figure it out when we get there. Some little orange spacers. A little T-arm. It's got a hole on that side and a hole on that side. A little gear. Axial gear. Another shaft. Another white LED. And another red LED with another trimmer. Maybe the white LEDs go on the bottom, so there's some real good contrast for the photoresistor to pick up on the reflection. There is the IC that does something or other. Looks like a Texas Instrument part. We'll look it up in a little bit. More end caps, more spacers, another transistor, and some more screws and spacers. So that's it. Obviously, oops, almost forgot one of the screws. So obviously there's not a lot of electronic assembly on this. Probably oh, I know what these are. These are going to be where the shafts for the wheels mount. Well, it's a good thought, but it's not deep enough for that. Again, we'll figure it out. Yeah, most of this is going to be mechanical assembly more than electronic assembly, which is just fine. Okay, we've got the build guide up. I also looked up this TI part. It's a op amp. It's a voltage comparator. So it's going to be the logic that senses the downstream voltage from these photoresistors to tell it if it's centered on the black line or if it has to go one way or the other. So that's a pretty easy schematic, and again, they do include the schematic here. So here's the sensors, and yeah, the 2 LEDs are providing the light, and then these photoresistors are picking it up, feeding it into the LM393 op amp to figure out what's going on, see what the differences are, feeding it to the two transistors which are driving the motors, and the motors have the red LEDs. So it's a pretty simple circuit, but it's pretty elegant. I kind of like this. I like the way they've done this. And we have a PDF of the build guide, some good illustrations, which I love. Yeah, lots of pictures. Good, 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 good. Now this is A-OK. How am I going to hold this? Oops, and I'm throwing the socket around. I'm going to hold this. I'm not going to put this in a vise or a stand today. And you'll notice these motors are going to be mounted vertically. I think I'll just use my silicone rubber grippy pad from Austin Ribbon Mics, link in the description. So it says to just basically put all the electronic components on. So we'll do that. And the components do have their value listed, I think. Yeah. So we'll just go in order. I may speed up the camera on this because, again, there's nothing particularly interesting here, even though I do have to straighten out the pins on the socket. I'm going to put the socket on first because that's what I have in my hand first. And the board is so wide open that you don't have to really think about it. I really, you know, I'm looking at this and saying, this would be a great kit for a beginning builder, because as I said, the circuit is pretty elegant and easy to understand. If you look here on the back of the circuit board, you can see that the traces are very clear, broad, and easy to follow. So as someone's building it, or once they're putting it into operation, if they want to follow along and see how the signal flows all the way along, it's easy to do, which is very neat. I like that. So now we're going to do some resistors. The 51 ohm. 51 ohm. Who decided that 51 ohm was going to be a good value? I don't think I've ever used a 51 ohm resistor in my life. I'm going to double check the value of this. No, it's dead on, 51.1. That's pretty good tolerance. There's all the top side electronic components. Now next step is to do some of the one of the main mechanical components, and I've zoomed the side camera in a good bit here because I think it'll be instructive on this kit. Now we're going to do the front wheel, for lack of a better term. We're taking this screw and we're going to take a nut and run the nut down on the screw. I'm going to tighten it. Now we put an acorn nut on the end of it, because that acorn nut is what it's going to glide on. Now the next step is to put the photoresistor and the light source down here on the bottom side, and they indicate that you will want to have the photoresistor and the diodes. The photoresistor will go about like so, about halfway up the threads, and then the diodes, the LEDs, the white LEDs, which are providing the light source to get these photoresistors to work correctly, will be about parallel with them, like so. The key thing here is you don't want the actual light emitting part of the diode, and you can see it in there of course, to be above the photoresistor, because if it's above, like so, then it's going to be shining down directly on the photoresistor and probably not providing the best signal. Now, it's interesting, I don't know if you're noticing, I'm fumbling a little bit here, because there's no solder pads on the back, on this side, so I'm going to have to solder it from this side to hold this at the height I want. I'm going to do the photoresistors first. Put the LEDs away. I'm actually going to use a little piece of painter's tape to keep the other side down too, because I don't want to use two locking tweezers. Never mind. There's, like they say, there's no kill like overkill. And again, obviously, adjusting the angle and so on is going to be easy. The leads are flexible. Let me trim this off. Now let's get the other photoresistor and try and match the heights. One of the reasons why I like it as a beginner kit, besides the ones I've already mentioned, is the components are really spaced far apart. So there's not going to be any worries about bridging contacts. So the young builder is not going to get frustrated by trying to solder really tight connections. Okay, let's get this about right. As you can see, we've got a light source and a light receptor, little cast ring thing. One thing we'll play with it, but I can see it might be valuable to maybe put a piece of cardboard or even a piece of, make up a little black electrical tape shielding so there's no cross bleed between the two LEDs and photoresistors. I may be over engineering that. That might not be necessary at all. Just I'm thinking about it as I'm looking at the design. Okay, so that's the driving part. I mean, that's the which way do I drive sensing part. Okay, now we're going to put the battery box on. Okay, battery box is installed. Oh, and now we're ready to actually, we still don't have the op amp in, but that's okay because we're just checking basic connectivity. We're going to get two AA batteries and see if we can get the white LEDs to come on. I'm going to make sure the switch is in the out position before I put the batteries in. Okay, so at this point, press the on switch and the white LED should go on. What the? Huh. Well, I guess they're not white LEDs. I guess they're clear LEDs with red elements. Okay. I was wrong about that, but that's okay. Okay, first we're going to prep the board area. We're going to take these little screws, put them through there, take these orange gaskets, and run them down. So there's the prep for the axle. Now we're going to build up the wheel assembly. So we start by taking axle pin and putting it through. I'm going to get a little tack hammer to help me with this. I decided hammer's overkill. I'm going to use Allen wrench to tap this in. Oops. Seems to be centered. Okay, so installation order. Now we put one of the three-way sleeves I pointed out before on the shaft. And there's a lot of space. It rotates very freely. Now we put another gasket on. And that's friction fit. That's not loose. And we'll make a final adjustment on that. And then we put a gear on. And the gear again is very tight. But now the goal is to have the gear through that slot and the wheel on the outside. So I'm gonna, and as I'm pushing this, the axle's coming out the end of the wheel, and I don't want that. So go back to here. Theoretically, let's keep checking our, okay, that's because, let me go further down here. We've got another, right. So we want to make sure that there's enough, that the gasket is allowing the wheel to not rub against the side there. So we're trying to get two things done. We're trying to make sure the gear goes in the slot appropriately, and that there's enough play or enough space for the wheel to not hit the side of the PCB. Again, if you've got a young builder doing this, you'll probably want to work with them on this, because this might be a little bit frustrating. And I'm not going to be able to lock it, because the gasket, if I had another gasket on this side, I could lock it, but I'm not able to. So it looks like it might be a little sloppy. But that's the way the stack goes. And now we take another one of the three ways and put it on here. Yeah, you're going to be able to adjust these with a little screwdriver pretty easily. So that's the build. That's the stack. And I didn't put the rubber ring on the wheel. I should probably do that before I lock this all down so I don't screw anything up later on. Oops. And of course I dropped the little T. So let me go find that. Fortunately, it didn't go very far. So we're going to put these on there, and I was wrong about worrying about stripping the plastic shim they're supposed to strip, because we're going to be screwing the teeth thing in there. But again, don't over tighten. Okay. That rotates okay. Now we'll do the other one. And there we have it. And yes, you're right, I did forget to put the rubber ring on it. So that's what we've got. It'll roll around like that. Next step is to put the motors on. The motors go here and here, and we'll screw them in place, and we're going to be running, they gave us this 4-conductor wire, and we're going to be running wire from the motor to these points. So just to make it a little easier on myself, I'm going to solder the wire onto the motors before I put the motors on. That's not the order in which they have illustrated, but I know it'll make it easier for me. Okay, so we're going to mount the motors now. They take these little bitty black screws. Move this out of the way. And once again, this happens more often than I would like. The screws are countersink screws. In other words, they've got an angle under the head instead of being flat under the head. And I don't know why they do that. Flathead machine screws are just as, don't cost any more or less than countersunk screw heads. And of course, if you're using a countersunk screw head and the hole in the PCB is not provided with a countersink, it's not bored for a countersink, then the screw's not going to sit flat. So I don't know why they do that. It's a minor thing, it doesn't cause any problems, it's just if you're going to engineer something and do a good job like these folks certainly have in this kit, it's all the details. Get all the details right. Now again, I'm not going to tighten these hugely, just snug them down. Now I'm going to solder the power cables in. Get my tweezers again. Of course, when you're doing this down here, you want to make sure you don't bang your soldering iron against the gears. That would be bad. Let's put the worm gear on now. Oops. And again, this is a tight fit, which is good. And you don't want to put it all the way on, just enough so the gears are meshing. So don't try and drive it until it's flat with the... So you can try them. Turn them with your fingers and see the wheels turn. Okay, that is ready to go. So I'm going to turn off the cameras and reposition, because we're going to try it for on the floor. And the observant among you will have noticed that I didn't put the op amp in. I corrected that. So we're going to power up and see what it does. We haven't adjusted the two trimmers at all, and there's no guidance on how to do that. I'm not sure. I'll have to look at the schematic again and see whether that's controlling motor speed or whether it's controlling sensitivity from the photoresistor. But we're going to hit the start button. We got lights up. There we go. It picked it up. Look at that. Oh, look at that little thing. That's so cute. It doesn't always pick it up, but when it does, look at that. That's really cool. It's as if sometimes this is too tight a turn for it to see, but this is pretty good. No, you can see when it does pick it up, it picks it up very well and tracks well. That's probably something I can tune, again, with the trimmers, so I'll look that up later on. I'm going to turn the cameras off and do one more thing. So I've laid some electrical tape down, and we'll see if it follows this. Oh, look at that. Look at it go. It's following right along with that tape. Now it'll see if it makes a turn, and it does. Now it's confused. Well, let's put it back on. It's binding on something there. But look at that. Okay. And I'll tell you what. I'm very happy with this thing. This is a great kit to build. It has great instructions, a little problem with some of the English, but not bad. A great schematic. And obviously it works. This is a superior kit for a young builder who is going to be all enthused because they can learn something, they can solder some stuff, and then they get something that actually does something neat. And then they can also put on their resume competent in multi-sensor digital autonomous vehicle operations if they want. So again, the link is going to be in the description. It's a great kit. Highly recommend it. Hope you enjoyed this.